Algebra 2, Section 14.5, the law of cosines. The law of cosines works much like the law of sines in that it's a simple formula that you can pretty much just take information from a triangle and plug it in to find information that you don't have. It is a bit more complicated as you look at it here than the law of sines. That's why we teach the law of sines first. If you could use the law of sines, you should. It's a little bit simpler. The solving amount of space that it takes, the number of steps is a little bit less usually. Okay, but anyway, the law of cosines is what you see here on the screen, and it's c squared is equal to a squared plus b squared minus 2ab times the cosine of c, and a key point there that capital C is what we're taking the cosine of. All of these lowercase letters here stand for side lengths. The capital C stands for an angle measure. Okay, so we already know that the way we name triangle vertices is by capital letters. All of these then would be the sides that are opposite the vertex that is labeled with that capital letter. Okay, so we're not going to actually do these problems. I have examples on the presentation software, but just to point out what would happen if we were to solve these problems, lowercase a being the unknown on this problem, is that you would take 84 and plug that in for the only place that angles can go. This length right here would have to go in here then. Okay, and that's kind of the key point to make about the law of cosines. If you only hear me say one thing about the law of cosines, it is this. Capital A and lowercase a on this triangle are opposite each other. They go in opposite locations on the law of cosines. Okay, this angle goes here. It's kind of the right bookend. This side length goes here at the left bookend. The other parts, 24 can go here, 43 could go in here. If you reversed those, it wouldn't be any big deal at all. 24 also needs to go in here where 43 goes in there. But again, if you flip those around, if this is 43 squared plus 24 squared minus 2 times 43 times 28, cosine of 84, or if this is 24 and this is 43, 24, 43, the 84 still needs to go in for C. Okay? Notice, before I mess this picture up anymore, notice that you can't use the law of sines here. In order to use the law of sines, you had to have a side length and an angle opposite each other where you know both. Well, I don't, the only angle I have is 84. I don't know this side length right here. And there's no other angle for me to get. There's no using the triangle angle sum theorem here. Okay? The same thing is true on the next problem. I don't know any of the angles, and there's no way that I can get them using any method, including the law of sines. To use the law of sines, you have to have an angle measure opposite a side length, and I don't have that angle measure. Okay, so just so you know, in this problem, the angle that we want to find, T, would go here. 6.8 would have to go here. And then again, 9.2 and 9.5 can go in for A and B in either order. Okay. Now, the last thing that I want to, the point that I want to make before we do some examples is that the lettering of the triangle doesn't matter. I called this triangle here ABC, but notice that I ended up plugging A, which is 84 degrees, in for C. We have to use some letters to give you the formula, and they decided to use ABC. Here you have a completely different named triangle, triangle TUV. Okay, so how does that work? Here it says, you can read it if you want to, about stars. They've already drawn the triangle for us, and they want us to find the length that is the segment BC, or what I'm going to go ahead and call capital A. So our law of cosines formula, and yes, we would have made you memorize this year. You were exposed to this in geometry, in which we gave you the formulas. This year, had you been here and took the quiz and the test, you would have had to memorize this. C squared is equal to A squared plus B squared minus 2AB cosine of capital C. And the way that looks in this problem is that A is going to go right here, is equal to 9.5 squared plus 4.6 squared minus 2 times 9.5 times 4.6 cosine of 43. Your calculator needs to still be in degrees. That's going to be just true for the rest of this chapter. I don't think we'll ever use radians again, actually, in this class. And then you're just typing this into your calculator. And I didn't do this ahead of time, so pardon me while I do the same thing. I've got my handheld calculator here, and I'm just plugging in 9.5 squared plus 4.6 squared minus 2 times 9.5 times 4.6 cosine of 43. And that comes out to about 47.5. A squared is approximately 47.5. Now, I've made emphasis on exact values before. I'm going to do it again right here. Don't take the square root of 47.5 and think you're going to get the right answer. You need to take the square root of the number that's already on your calculator, the square root of the answer. For most calculators, that's second, and then the x squared button is the square root, right? So second x squared, second negative key. You're taking the square root of the answer. You'll get a more accurate answer. Sometimes it will be off by a tenth if you don't do this. And if I round to the nearest tenth for this one, it's going to be 6.9. Watch the directions in the book about what they say to round to. Also on Khan Academy, watch the directions. I got 6.9. Okay? And that would be, I think it was light years. If you look at the example, it's 6.9 light years per units. Now that's how you solve for a side length. You can use the law of cosines to solve for an angle measure as well. Here's a different example. They've already got the triangle labeled again. They say find the measure of the angle opposite the longest side. Well, that would be angle C here. They'll just come up with different creative ways to ask for things. I mean, they're asking for angle C, capital C. Now in this case, and let me just write it out one more time. In this case, C actually is C. Capital C, the angle that we're trying to find actually is the unknown angle that we are actually going to plug in for capital C. Lowercase c needs to be the 14. 14 squared equals 9 squared plus 11 squared minus 2 times 9 times 11 cosine of capital C. Okay? Now, I know that 14 squared is 196. 9 squared plus 11 squared is 202. And then 2 times 9 times 11 would be 198. Cosine of C. Sometimes students have a problem with what I just did there. I did that correctly. You can do this math right here separately from this math right here. Okay? There's a subtraction sign in between. You don't want to combine those things, but rather you can do this, and it's necessary that you do simplify those things. Now, here's where the biggest pitfall happens. Be careful right here. Very often, these two numbers are close together, and the temptation is to subtract them. But don't you know that this operation right here is multiplication? So this would be like saying, oh, I'm going to go ahead and, if it's 5 minus 3x, oh, that's going to be 2x. That's not going to be 2x. This is multiplication. Multiplication supersedes subtraction. In the case of the law of cosines, we're trying to solve for this angle C here. So rather than subtracting, which you should not do because that would be a violation of orders of operation, you're going to need to subtract 202, divide by negative 198, and then take the inverse cosine. So I'm going to do that one at a time. Again, I'm just using my handheld calculator here. 196 minus 202 is negative 6. Okay, now you might have been able to do that in your head, but we're going to start to get a running number on our calculator. You probably can't divide negative 6 by negative 198. So now you need to divide that number by negative 198. And it's approximately 0.03. And then the last thing we do is take the inverse cosine of the answer. And again, please don't take the inverse cosine of just 0.03. That will not give you an accurate answer, but rather use your calculator to take the inverse cosine of the exact value that was already on your calculator. And the measure of angle C here is 88.3. If I'm rounding to the nearest tenth, which they did say round to the nearest tenth of a degree up there, 88.3 degrees. Yep. All right, now, one more thing. Notice that on this problem, they want you to find angle Q. Angle Q is here. And not only can I not use the law of sines here because, again, the wrong information is given, if I go ahead and do the law of cosines, I can't include the angle Q. There's only one place to put an angle, and that's where the 32 has to go. Okay? But there is something to be solved for on this triangle, and you're just going to have to go with the information that's given. So solve for P, lowercase p. Here's capital P, here's lowercase p, and go with that in the law of cosines. Now, you've already seen me do it twice, and let me just kind of roll to their work, which would look like that. P squared is equal to 12 squared plus 10 squared minus 2 times 12 times 10 cosine of 32. If you solve, then as we just did in the first example, you'll get about 6.36. Once you know that, actually let me ask the question here. You think about this. Once you know that up there, that length that is lowercase p, is about 6.36. What can you do with that? We want to find angle Q. What could we do? Now, if your answer was use the law of cosines again, you're correct. If your answer was use the law of sines, you are also correct. You could do either one. There is one interesting thing. I could fill the next 20 minutes of a video explaining to you just exactly what's going on here. But if you're interested in this, go ahead and try it yourself. It would just take a few minutes using each one. If you use the law of sines, you would find out that angle that we want to find for angle Q is 88.4 degrees. If you use the law of cosines, you would find that angle is 91.6 degrees. Why the difference? I gave you a hint in the email to the law of sines that address this, and this is called the ambiguous case. And again, without giving a really lengthy explanation, if you were to use the law of sines, you would use angle Q and 12, angle 32 and the 6.36. You wouldn't know that this side is 10, okay? So in that case, it could be the case that the angle is a little bit smaller. The angle Q is actually more like this. If you can see what I'm drawing there, the angle Q is out here. Now, if you use the law of cosines, you would incorporate the 10, and then you couldn't extend that side length. Bottom line is there's two possible answers for this. It depends on whether it's an obtuse or an acute triangle. Notice something though, and this will be a focus in a class that you take next year, so the fact that we're not getting into this too much is not a big deal. Notice this much though, those two angles add up to 180 degrees. So if you get an angle and you think it's right and you've done your work right, but it's not the right answer, subtract it from 180 degrees and you probably will have the right answer. Okay, thank you for watching, good luck.